So I'm going to introduce you to Simio. This is a custom application developed under the Rockwell Factory Talk View platform for our Factory Talk View SE, and it is a PLC simulator and accompanying program. If you're interested in obtaining this version, you can email me or text for a quote. This is an application that develops quite a few hours of programming, and so it is available for a one-time purchase, but you must have your Factory Talk View SE software installed to run this. If you are a university, which is primarily what this is geared to for a training solution, then if you are a Rockwell Educational Toolkit member, you have this already. You simply have to install the software. So if you're a Rockwell Educational partner, then you have this, and you can run this application in your labs. So we open up Simio. Once we open up the shortcut, we acknowledge user agreement. If you have to, you hit the refresh button, but we'll see that once we have an IP address here, that we are connected to a processor. So we're going to open up the processor. As long as you're displaying an IP address up here, you are connected to a processor. If you lose connection, of course, this will blank out and everything will turn gray. So how this piece of software works is there is coding behind each one of these buttons that make these buttons behave either normally open or normally closed. And when we cycle this one time, we activate that software, and we'll see that this IEC symbol is showing normally closed now. We can activate this. Notice that it is tied into a physical address. This card does not actually exist in our rack. It is inhibited, which allows us to write data. Typically, you would never do this in the real world, but since this is a simulation, we are actually going to program with physical I/O, more realistic simulation. There is an animation here. Students should stay out of this. This controls some of the lighting and the motor. So here, if we go to our controller tags, we'll see that we have our address listed. This is local:4:I.data.0. So we're going to browse to that card, and that is card 4 in our I/O rack. This version is also available in a SoftLogix. So if you are a Rockwell Educational Alliance member, you don't even need a processor. You have everything you need in that package that you can run this and run a simulated PLC and a simulated trainer. That's what you choose to do. I will tell you that using SoftLogix sometimes has some issues as far as having to restart the PC and everything, but that's just the way it is. What we do is we use Compact Logix in our labs, which with our Educational Alliance partnership, we're able to purchase those at a discount through our local distributor. And so we're going to open up our data. We'll see that this is a 1, and it behaves as a normally closed wired stop button. If we look over here, pull this over here, we'll see that we can, the students would add their descriptions, etc., etc. Notice that I have a description on the screen. This data here is stored in the processor. And so if you're doing a simulation or whatever, the students can rename these to whatever motor stop. They can rename this to whatever name they want to call it. This, however, does not update the descriptions in the processor. It just simply stores these names. So you have the option of naming these whatever you want to in your program. And all of these are tied into these physical addresses. You also have a motor simulator. So you have a forward reverse motor with 3 prox indicators that represent the position of the motor. there is actually a feedback signal, normally open and normally closed, from the motor contactor with a slight delay. So it represents the delay of the mechanical action of the contactor closing, just like you would have in a real PLC controlled contactor. So if we want to go here, we can see that motor reverse is on card 5. We're going to come over here to output card 5, and we're going to open up the data. I'll see that that is actually .1 and .0. If I just simply put a binary 1 in here, I can see that our motor begins to spin. As it makes our prox indicators, they begin to highlight, and so I can write code programming those for any kind of usage. So, quick example program. Let's say we want to add a button to start a motor. They would add that under the main program, the continuous program. So we'll say we'll drop this in here, and we'll add our output. This out. We'll add a button here to control it. That's going to be, we'll just pick a green button, and we'll browse all the way down here. This would be exactly how you program in industry. You would browse to that address card, pick up the data. We're going to do .1. Doesn't have a description. It's marked unused. We'll call this one the left start button. We will accept the edits, assemble the edits, make them permanent. Pull this over so we can see everything. Assemble all the edits. Yes. And then we'll hit the left start button. You should see that motor begin running the other direction as long as we close that. You also see the indicators begin to become active as it makes. So that's your introduction to Simio. You can use a lot of your other standard programs, forward, reverse, et cetera, but you have your stoplights. You can do count up, count down pairs using the proxies. You can do cascading timers. Everybody likes a stoplight, so you have 2 stoplights here. So that would probably correspond to a lot of your material that you already have.